Hello, my name is Fatih Furkan Erkic. In this practice lab, we will implement a decision tree from scratch and apply it to the task of classifying whether a mushroom is edible or poisonous. Let's run import libraries. Problem statements. Suppose you are starting a company that grows and sells wild mushrooms. Since not all mushrooms are edible, you would like to be able to tell whether a given mushroom is edible or poisonous based on its physical attributes. You have some existing data that you can use for this task. Can use the data to help you identify which mushroom can be sold safely. The dataset is used illustrative purposes only. It's not meant to be a guide on identifying edible mushrooms. Okay. You will start by loading the datasets for this task. The dataset you have collected is as follows. Here we can see here. You have 10 examples of mushrooms. For each example, you have 3 features: cap color, brown or red, stalk shape, tapering, as in like that, or enlarging, as in like that, and solitary, yes or no, and the label, 1 indicating yes, 0 indicating poisonous. One hot encoded dataset. For ease of implementation, we have one hot encoded the features, turned them into 0 and 1 values. Therefore, Xtrain contains 3 features for each example: brown color, a value of 1 indicates brown and 0 red, tapering shape, 1 tapering, 0 enlarging, solitary, 1 yes, 0 no, and white rain, y equal 1 indicates edible, 0 indicates poisonous. Let's run it. View the variables. Let's get more familiar with datasets. And same on the white rain. Check dimensions of your variables. And decision tree refresher. In this practice lab, you will build a decision tree based on dataset provided. Recall that the steps for building a decision tree are as follows. Start with all examples at the root node. Calculate information gain for splitting on all possible features and pick the one with the highest information gain. Split dataset according to selected feature and create left and right branches of tree. Keep repeating splitting process until stopping criteria is met. In this lab, you will implement the following functions, which will let you split a node into left and right branches using the feature with the highest information gain. Calculate the entropy at a node. Split the dataset at a node into left and right branches based on given feature. Calculate information gain from splitting on a given feature. Choose the feature that maximizes information gain. We'll then use the helper functions you have implemented to build a decision tree by repeating the splitting process until the stopping criteria is met. For this lab, the stopping criteria we have chosen is setting a maximum depth of 2 and calculate entropy. First, you will write a helper function called compute_entropy that computes entropy, measure of impurity, at a node. This function takes is an NumPy array y that indicates whether the examples in that node are edible or poisonous. Complete the compute entropy function below. Okay, here's our function. Note the log is calculated with base 2 for implementation purpose. 0 log to 0 equals 0. That is if p1 0 or p1 1. Set the entropy to 0. Make sure to check that the data at a node is not empty. Len y not equal to 0. Return 0 if it is. Okay. Let's complete this code. We define a p1 make if statement len y not equal to 0, p1 equals to len y equal to 1 over len y. And if p1 is not equal to 0 and p1 not equal to 1, entropy equals to negative p1 times numpy log 2 p1 minus 1 minus p1 times numpy log 2 1 minus p1. Okay, let's run it. Let's check the implementation. All tests passed. Okay, split dataset. Next you will write a helper function called split dataset that takes in the data at a node and a feature to split on and splits it into left and right branches. For example, say we are starting at the root node, so node indices 0 to 9, and we choose to split on feature 0, which is whether or not the example has brown cap. The output function is then left indices 0, 1, 2, 3, 4, 7, 9. In here, data points with brown cap and right indices 5, 6, 8 without a brown cap. In this exercise, we complete the split data set. Let's start coding in here. Let's make a loop for e in node underscore indices if x I feature equals to 1, left indices append I, else right indices append I. Okay, let's run it. Now check the implementation. Okay, we have an error in here. I think, what is the error? Oh, we made a mistake. It should be like that, uppercase X. Okay, let me restart it. It has an error. I didn't understand the error. Maybe it's about the Pydot library. Maybe try install it. It's already installed, but we have an error. Okay, let me check the error and I will continue the video. Okay, I installed Graphviz and it's solved. In here we have first splitting and second splitting and all tests passed. And 4.3, you'll write a function information gain that takes the training data, the indices at a node, and feature split on returns information gain from the split. We will complete the compute information gain function shown below to compute this function. So let's write it down. Node and hope equals to compute entropy why not? And left hand trophy, y left, and right hand trophy to y right, with underscore left equals to len x underscore left divided by len x node, and probably right equals to len x right divided by len x node weighted trophy equals to double underscore left times left entropy plus double underscore right times right entropy information gain equals to node entropy minus weighted entropy, and that's it. Let's run it, and let's run tests, and all tests passed. Get the best split. Now let's write a function to get the best feature to split by computing the information gain from each feature as we did above and returning the feature that gives maximum information gain. We complete the get best splits function show though, and let's write it. We define a max info gain which equals to 0 for feature in range features info gain equals to compute information gain x y node indices feature, and if info gain greater than max info gain, max info gain equals to info gain, and best feature equal to feature. Let's run it and let's test it. All test passed, and building tree, let's run it. And here we have edible and leaf not, poisonous leaf not in here, brown and kept, and leaf not edible, leaf not poisonous. Okay, that's it for this homework. Thank you for watching. Have a nice week.